Hey math kids, today we're going to talk about the angle between a line and a plane, and we're in chapter 7, section G, and it says the angle between a line and a plane is the angle between the line and its projection on the plane. So we're going to look at example 13 and just kind of talk about this idea. So it says, name the angle between the following line segments and the base plane TUVW. TUVW, and we have a rectangular prism that I will do my best to draw. And we have W, there's an X marked right there, V, U, R, S, P, Q. All right. I'll draw these in too. Okay, so we have this, and it asks us to find P, U. So we're going to mark PU, which is going to be a line segment, just so we can see it visually. And so the projection of PU onto the plane is TU. So if we're trying to put it on TUVW, oh, T is back here by the way. So TUVW. So we're kind of focusing on this plane that's right here, the bottom. So if we project this onto this, it becomes TU. Okay. And then the required angle that we need is going to be this one, which is PUT. Okay. Now it also asks about QX. So if we draw QX, we want to get projected onto that plane. And so to do that, we're going to have to go to U. So we get the projection is XU. And so the angle that's created is the one that's right here, which is QXU. And that's what it was asking for. So let's move on to the next one. So it says the diagram shows a cube with side lengths 12 centimeters. So let me draw this cube. Let's get rid of this. Okay. It's a lot of letters. So E, H, M, G, D, C, B, A. And this one's F. Okay, I think I got all those. So it says that all the side lengths are 12, and M is the midpoint of these two, so those are the same distance. So HM would be 6, and MG would also be 6. It says find the angle between the following line segments and the base plane EFGH. So once again, we're dealing with the bottom, EFGH, and it wants us to look at AH first. So we're going to draw AH. So we have the line segment there. And if we want to project it onto that base plane, we're going to get EH right here. And so the angle that we're going to look at is this. So AHE. And this time they want us to find the actual value of that angle. And so this problem just becomes a right triangle where we know the base is 12, the legs are both 12, and there's some angle that we want to know. And so it becomes a SOHCAHTOA problem. And what we want to do is figure out which one. So we have opposite and adjacent, so that's tangent. So tangent theta equals 12 over 12. So tangent theta equals 1. And we do the inverse tangent of 1. Go to our calculator. We make sure you're in degrees. Mine's already in degrees. Actually, I need to reopen it. It froze. So we go mode, degrees, then we do the inverse tangent of 1, and we end up with 45 degrees. So that angle, the one for part A, so this angle is 45 degrees. Okay, same picture. This time we're trying to find BM. So we go from B to M, and if we do that, our projection angle is BMF, because we want to be on that plane. And so we essentially, we want to find this angle. That's the goal that we're trying to find that. So BMF. Okay, so we need to find a few things out. So let's see. We can draw this triangle, and that's going to be a part of it, but we're going to be missing some things. So we have theta, which is what we want to know. We know this is a right angle because it's perpendicular right there. And we know the height of this is 12, but we don't know FM. And we don't know the hypotenuse either, but we want to find FM. So if we look at this right triangle, where this is the right angle, so I'll draw that one. If we look at that one, we know the distance of this leg is 6. We know the distance of this one is 12. And so we can use the Pythagorean theorem to find FM, which would be the hypotenuse in that triangle, which we'll end up using right here. So if we use the Pythagorean theorem, we're going to say 6 squared plus 12 squared equals FM squared. Move that over a little bit. So 36 plus 144 equals FM squared. Let's see, that makes it 50. So 180 equals FM squared. And so FM is the square root of 180. Okay, so now I can plug that in here. And Then we just use our right angle trig. This is going to be a tangent situation. And so we have tangent theta equals opposite, which is 12, over adjacent, which is the square root of 180. And then we use inverse tangent of this number to get that. So we're going to say inverse tangent, second tangent of 12 divided by the square root of 180. Yeah, that looks good. Is 41.8 degrees. So that's saying that this theta right here is 41.8 degrees. Alright, so I know my figures aren't the best. You can look in the book to see better figures, but if you need additional help, come to Math Lab. But for now, calculator.